see, possibly. We'll have time. I want to do a lot of FRQ stuff too when we're done with the whole unit. I think that's the big thing. But yeah, I mean, those are an option too for us to get some practice. We did not get anywhere near them last year. I also have there's also 3 released international AP tests, the ones they give to international students. So we have some real AP multiple choice to look at there. Okay, so like I was saying before, I remembered to record. The big distinction between, especially with particle motion with AB and BC, is we obviously learn all of the particle motion in BC, but we've already looked in our last unit a little bit about two-dimensional motion. Generally, in many years, there is a particle motion FRQ on the AP test. If there is a particle motion FRQ, usually it's different on the 2 tests, and AB gets a one-dimension particle motion. And usually the stuff that you guys will get will be the 2D particle motion. So although we're going to do a lot, we're going to spend 2 days on this. I'm going to give you a good amount of time to work because I think it builds the foundation for what your questions are going to ask. I hate to say it, these are all going to be easier than what will actually be on your test. They're not easy, but they are easier because you don't have to do any of the extra stuff that comes with doing it in 2 dimensions. Just like I said the first time we did this, everything has an analog. The only thing we haven't done is worked our way back up the derivative ladder. So if I have a velocity, answer the question, how far did I go? If I have an acceleration, well, how much did my speed change? But that's what integrating does, right? It tells you what the change is based on the rate. So we've got a graph that I've kind of shown here. The 3 big questions that we can ask, this is a graph of velocity. So we're looking at velocity, the most common thing to get, because then we can get back to position from it. I kind of did it, this is purposely done like this, where we have a positive area, a negative area, and another positive area. We are going to assume that the numbers that are in here are all positive. So if we want to take this quantity away, we're going to subtract it. I could have done it either way, but we have to decide. So we'll think of all 3 of these numbers as positive numbers. And then, because this one is under the curve and it's positive, we'll have to subtract it to use it the correct way when we need to do that one. So integrating that velocity will tell me my displacement. How far am I from where I started? So if I integrated v of t dt, whether this was velocity or anything else, that solution would be a1 minus a2 plus a3. With the caveat that a2 is a positive number, so that's why we're subtracting it. Now, what if instead I wanted the total distance traveled? What would I do with those 3 numbers? Yeah, I would add them all up, right? Because the idea is I have traveled a1 units to the right, or the particle has, then I've traveled a2 units to the left. So I've traveled both of those things. That's a 1, I'm going to fix it in a minute. And then it traveled a3 units to the right. And then our first typo of the day here, I just have the integral written here. If I want to know what the actual position at any time b is, then I need to know, where's the way I have this? Yeah, I guess I should have this. This was brand new, so I can see a lot of bugs in this one as I was working it, but I'll just change them as we talk them through. If I want to know where I am at that, well, then I have to take I need to know my starting value. I need to know where I was at time A, and I take that and I add the displacement. Yep. I said, yeah. Thought I had the word any in there. There we go. So yeah, actual position at time B, given that x of A equals C. So that would be C plus A1 minus A2 plus A3. Okay, so those are the 3 big questions. We put 2 of them on a card today. We'll put the 3rd one on a card tomorrow. But with displacement, we're integrating the velocity. with total distance traveled, we are integrating the absolute value of the velocity. Both of your cards should have x primes on them, or v's, now that I'm looking at them. Let's do v, that's the more common one. Sorry about that. As I was doing my notes, I made the executive decision to simplify the equation that I gave you guys here. Example 1 says a particle is traveling on the x-axis with a velocity given by v of t equal to t squared minus 6t from time 0 to 9. How far is the particle from its original position after 9 seconds? That's displacement. So I am just going to integrate the velocity from 0 to 9. So that's the integral from 0 to 9, t squared minus 6t dt, which is just power rule, so t cubed over 3 minus 6t squared over 2. Evaluated from 0 to 9. So I need to do 2 subtractions and subtract those. It's probably always a good idea to just have that in your head before you start writing stuff down, because it's really easy to lose your parentheses in these problems. So I've got to cube 9, but then divide it by 3. So I square 9 and multiply it by 3. Cut out the middleman there. 9 times 9, then times 3 instead of 9. You cubed it. I don't know what you did. 243, yep. So I was thinking what I had to do, right? I had to multiply 9 times 9 times 9, but then I have to divide by 3. So I took that last 9 and I divided it by 3. So 9 times 9 times 3, yeah. 243. And then this isn't 6t squared over 2, it's 3t squared, which is 9 times 9 times 3, which I don't do the same math problem twice in a row. I get 243. Right? 9 squared times 3, same thing. Weird the way that one worked out. Cool. So 0, hey, that's easy. Now I got to do that with 0. Oh yeah, that. Then we get 0 cubed over 3 minus 0. Yeah, okay. You know, I made that change to the problem, but I never redid the first part. Yeah, so it actually did move a lot, but it hasn't gotten anywhere. This is like me when I leave my phone out in the car in the morning. Yep, I've moved a lot. I had to walk back out and get it, but I'm back where I started from. Cool. So let's answer that question. How far did the particle actually travel in the first 9 seconds? So in order to do this, you have to figure out when it's going to the right and when it's going to the left. How do I know when it's going to the left and to the right if I have the velocity? Yep, velocity is positive or negative, yeah. So I'm going to set v of t equal to 0. Always smart to show that. A lot of times the scoring guidelines kind of say that. So just kind of, outlining what it is that you're about to solve. T squared minus 6t equals 0. Which, super easy factor, just factor out the t. T times t minus 6 equals 0. And we do a sign chart. And the 0, t equals 0, t equals 6 are the zeros here. So it's actually changing direction right at the beginning, but since it's the beginning, it's not changing direction. So it's an important number either way. So we'll make our sign chart from 0 to 6 to our, I guess I don't need the 9 here, but. So after 0, t is positive, but t minus 6 is still negative. After 6, t is positive, and t minus 6 is positive. So what we're going to do here, and there's a couple different ways to do this. The most general way is to integrate, take the absolute value of the integral. So integrate and then take the absolute value of that. Anytime it's negative, you're going to need, or anytime that number comes out negative, that just means you've moved that many units or whatever the measurement is to the left. So I'm going to make up two separate integrals. I'm going to integrate from 0 to 6, v of t dt. And whatever that result is, I want it to be positive, plus the integral from 6 to 9, v of t dt. It's moved this many units, and we know that it's going to be to the left, and it's moved this many units to the right. So now we've got two separate integrals to solve. We've got to do t cubed over 3 minus 3t squared. We've got to evaluate that from 0 to 6, and then take its absolute value, and then do the same thing. T cubed over 3 minus 3t squared from 6 to 9, and then take its absolute value. I definitely did not give you guys nearly enough the right amount of space here for this, so move some stuff out of the way here and we'll regroup. Why not? Too bad you can't do that on your paper. So let's see. We had a new thing to figure out. We've got to evaluate it at 6, but we're going to do that twice. So let's see. We've got two absolute values being added. And inside each absolute value, there should be a 2 term being subtracted. Yeah. All right. So we'll do that twice. One of them is just going to have zeros in it, though. Boom, minus, boom, minus. All right. All right, so the first is plugging 6 into the both of them. So I'm going to do the same thing I did before. So I'm going to do 6 times 6, and then I'm going to stop short of doing it the third time. 6 times 6 is 36, and then I've got to multiply by 6 divided by 3. So that's multiplied by 2. Yep, 72. And then 3t squared, that's going to be bigger, so that's going to be 36 times 3. Yep. Cool. And this is just 0 minus 0. Hey, I got to plug, there's another spot where I'm going to plug 6 in, but it's not going to be till the end here. Let's see, here we've got the 9, but we've already done that before. 9 gives us 243 minus 243. And then the 6 is the 72 minus 108 again. That wasn't too bad. And 72 minus 108 is, yeah, negative 36, yeah. So in this case, we have the absolute value of negative 36, which should match because we said we were going to the left from 0 to 6. And on the right, we have the absolute value of negative 36, so the absolute value of 36. So it does turn out that we went 72 units. I guess I didn't do any of these after I made the change in the problem, because letter C is kind of a silly question. If the particle started at x equals 10, at what location was the particle at t equals 9? Well, what was its displacement? 0. Yeah, so, yeah, 10. So it's 10 plus the integral from 0 to 9 of t squared minus 6t dt, which we've already solved. That's 10 plus 0. Yep. So it went 36 units to the left in the first 6 seconds, and then it turned around and it went 36 units to the right in half the time. That's what ended up happening. Okay, see you, bud. I will post the rest of this and we'll work on this tomorrow. Good luck. All Right, totally gave it up. Yeah, this was supposed to be cleared out there. Anyway, if the particle is traveling on the x-axis, sorry, just jumping right into a new one. So now we have a graph rather than a function. So this one should be a little bit easier. If the particle has position x equals 0 at time t equals 2, what was the particle's position at t equals 0? And this is the graph of the velocity. So at t equals 2, we were at 0. What are we going to do with this area to work our way back to 0? That's really the question. What's that? It's going to be negative, right? It is above the curve, but we're moving back. We're going back in time. We can really say that because t equals 2. If we were at 0 and we were going to 2, the bug was moving to the right because it's got a positive velocity. So if we press rewind on that, the bug is going to be moving to the left. So this bug would have a position of, right on that 1.5, right? Yeah. Yep, it's a 1.5. These are my least favorite person's graphs not the person, I don't mind her, but I hate these graphs, the way they look. Anyway, so what's my position? Yeah, negative 4.5. Yep. Yeah, so I was at 0 and I ended up at 0. I was moving to the right and I moved 4.5 units, so I must have started at negative 4.5. How far did the bug travel on the time interval from 0 to 8? So that is not displacement, that is total distance. So I've got to find all of these and treat them all like they're positive. A lot of 1.5s in here. Six. So I've got 3, 6, 12, 15, 16.5. Yeah. When was the particle furthest to the left? What's that? At t equals 7. How are you sure that it's t equals 7? What's that? It is the absolute minimum. It is the relative minimum, but how do you know it's the absolute minimum? We do know the starting point.
Oh wait, now we do.
Yeah.
Well, it decreases more.
Yeah.
Than it increases.
Right. So you really have to think about what we're really doing here on this one. And if this is an FRQ and you need to justify it, this is an EVT question, which means that you should make a table of values. Okay? You should consider the endpoints and you should consider the critical values. So x equals 0, 8, and the critical values of 3 and 7.
Should that be B?
It should probably be t, right? T's, yes. Yep. And then the next column will be v of t. We've already figured out that it was at negative 4.5 at 0.
No, that should be X.
That should be. That was the.
Oh, you're right. This should be x of t. Yes. Yep. Especially with what I said. We figured it was at negative 4.5. Correct. This should be x of t. When is it furthest to the left? That's going to be the lowest value we get for position. Yep. So if we're at 0, then at 3 we would be at 1.5. So then from that 1.5, we have to take away 1.5, take away another 6, and then take away 1.5. So those cancel each other out. I'm at negative 6, I'm at negative 7.5. But then in that last second, I'm going to increase by 1.5 to be at position negative 6. So as far as justifying, like I told Colin, I like the way you did it. Like, don't get me wrong, I was just thinking of the justification way on it. Like, this is clearly a bigger area than this. So running backwards in time isn't going to get you further to the left than this is going to take away. So yeah, but that's what they're sort of looking for. You've considered, like that's what the scoring guidelines will say. Considered the critical values, and then found the minimum, and that's what that chart does. Question on that? Okay, example 3. The word average, we're going to see it again. I mean, sometimes they just go right back to something that we've looked at before. A bug is traveling on the x-axis. The bug's velocity is a differentiable function given in the table below. Use a trapezoidal sum to estimate the integral from 0 to 10 of v of t dt, and interpret the meaning of this estimate in context. So that's the only part that's new. Okay, so trapezoidal sum, I'm going to have 4 intervals. 3, 4. Those intervals are different widths. That's totally okay. That happens sometimes. We just have to be aware of it. And then don't forget the correct formula to do. So what we'll say here is the integral from 0 to 10 of v of t dt is approximately, because we're estimating, and that's the last time I'll use the approximate sign, because everything after that is going to be equal to the thing before it. So what's my first interval going to look like if I'm doing trapezoidal?
1/2 times -2 plus 0 times 1.
Yes, so we got, say that one more time? Oh, because you do it, right, so you're doing it like that rather than the fraction. That makes sense. 1/2 times -2 plus 0. So that's the average of the two. We call them bases if we're thinking of a trapezoid. We call them heights if we're thinking about the graph. And then we've got to multiply that by the width, which in this case is 1. Right, so we will rinse and repeat with that one. So the next one's going to be 1/2 sum of the bases, so 1 minus 2. This width has an interval of, this interval has a width of 3. Once you kind of get, like, it's -2 minus 0, 1, -2 plus 0, 1 plus -2, -3 plus 1. That width is 2. Don't lose my negative there. And then 5 plus -3. Trapezoidal, it's 1/2 base 1 plus base 2. Yep, that's right from the area of the trapezoid formula. Yep. And then that last one has a width of 4. Did you do it? You do it the way I do it, where you just put this over 2? Yeah, I agree. Yeah, it threw me off when Aiden first said it. But they're both legit. They both do the same thing. It sort of gives me an order to do everything in, and I don't need to get distracted. So, all right. So this guy looks like it's -1, right? We've got a 1/2 times -2 plus 0 times 1. None of that does anything. So we've got a -1 plus, this does not feel like it's going to give me a whole number. So I've got -1 times 3, -3 halves. -2 times 2 is -1. Divided by 2 is -1. Times 2 is back to -2. And 2 times 2 is 4. So it looks like I have 2, 1, minus 3 halves. Agree? Okay, cool. Alrighty. So what does that mean? What does the integral mean? We're just going to use the word about. So what did we figure out? Displacement, yeah. So remember to always put your limits in there. If you're taking a derivative of the point, you've got to say at t equals that number. If you're integrating over an interval, then you have to say it during the time interval between 0 and 10. So during the interval What did the bug do? Or you said displacement, so we'll say the bug's displacement. I already don't like what I have written here. 1/2 unit to the left. I actually might say from the time t equals 0 to t equals 10. Now the way that I'm reading it, if I wanted to kind of, right? Because like during the interval from 0 to 10, the bug's displacement, I like the way it sounds better if I say from t equals 0 to t equals 10, the bug's displacement is 1/2. So I'll just fix that up. Cool. Letter B is an interesting one. This kind of goes back to what we were saying yesterday. The question here is, what is the average acceleration of the bug on the interval from 0 to 10? Average rate of change of the acceleration, is that what it's asking? No, the average acceleration, the average value of a function. To find the average value of a function, we integrate that function, and we also put that fraction in the front of it. Do we have acceleration in this problem? No, but watch what happens here. This kind of makes some connections. What is acceleration based on what we have? Acceleration is v prime, right? Yeah, so write that. A of t equals v prime of t. So to find the average acceleration from 0 to 10, we have to integrate 1 over 10 minus 0. We're not integrating that. We have to take 1 over 10 minus 0, integrate from 0 to 10, and we've got to integrate our function, a of t. I don't have that written correctly, do I? Yeah, I do. Yep. Never mind. dt. But a of t is v prime of t, right? So I could just as easily say that this is 1/10, get rid of that subtraction there, the integral from 0 to 10 of v prime of t dt. And now using the fundamental theorem of calculus, what's the integral of v prime? What's an antiderivative for v prime? V. So it's 1/10 v of t evaluated from 0 to 10. This is a parenthesis there. There we go. Which is v of 10 minus v of 0 over 10. Which does end up making it, like it is a difference quotient. They could have worded this differently and made our lives easier. If they had said, what is the average rate of change of the velocity, we would have jumped right to here. You know what I mean? And that was my whole idea that I wanted to get across, especially for these word problems yesterday. It really is. When we're asking you to find the average value of a function, we're really just asking you to find an AROC, but of the antiderivative. So I guess that's going to give me 5 minus 0 over 10. Oops, yeah, I thought I lost my 10, but that's why I have the 10 there. 1/2. I know I didn't give you any good units in this problem, but let's just say centimeters. Yeah.
Feet per second?
Yeah, feet per second. Oh, did it give me?
Yeah, VT is in feet per second.
Oh, in the table. I was looking up in the words. Yeah. Feet per second. Yep. Yeah. Yeah, which one would it be? Squared. And you can always go back and look at the question. They want an average acceleration. An average acceleration is a value for acceleration, so it's got to have the correct label for acceleration. So that would be feet per second. I usually write per second, but I'm going to go against my normal. Yep, and squared. Yeah. I feel like, in science, we have to say, well, how do you know it's that label? In AP Calc, if you're looking for an acceleration, you know it's going to be distance per time squared, or distance per time per time. All right. Letter C, and I think this is where we will stop at least with the notes for today. Yeah, and we'll do the calculator active one tomorrow. Is there a time when the acceleration of the bug is 2 feet per second? Justify. Just justify. No period. No justify your answer, but just justify, period. It all means the same thing. Little blast from the past here. Yes, by the MVT, right? So what do we need to say in order to use the MVT?
VFT is differential.
Mhm.
0 to 10.
You know what I would say, though, before I even jump to that, even though I have it up here in B, we are talking about acceleration, and you're jumping into V. Always put that there. A of t equals V prime of t. This way, anytime you're talking about V prime, you are talking about acceleration, which is the question that they were asking. But yeah, V of t, or yeah. Okay. Let's start. Reset. So now what do I want to say?
Differential.
What's differentiable?
VFT from 0 to 10.
V of t is differentiable. We want to know if there's a time when acceleration is. Do you feel like this probably should say okay, yeah, no. Yeah. Yep, no, you're good. Yeah. Sorry, I was wrong in my head. Yeah. V of t is differentiable. Yep. What else do I have to say? I know, it's ridiculous. V of t is continuous because it's differentiable. 9 times out of 10, this is what you're writing no matter what. And then we need to find what?
One of those average rates of change has to be 2.
Yeah, one of these average rates of change has to be 2. And which one is? From 6 to 10. Yeah. Yep, because that's an interval of 4, a time interval of 4, and a velocity change of positive 8. So time went up by 4, velocity went by 8. There it is. So then what I'll do is I'll just write that out from scratch. So I'll say the V of 10 minus the V of 6 over 10 minus 6. Over 10 minus 6 equals 5 plus 3 over 4. If you don't believe me that equals 2, you shouldn't be grading an AP test. Don't say that to the grader. Oh, yeah. The MVT, that's it. Those are the 3 conditions you need. Differentiable, continuous, show me the difference quotient, giving me the number. The MVT guarantees a time. You could, usually they give you a range here. This question just didn't have it. So either you reuse their range, use the range that you used. It doesn't matter. Interval, I'm saying range, but use the interval that you used, 6 and 10, or use the interval that they gave you. They didn't give us one, so we'll say between t equals 6 and t equals 10, such that, those are backwards, SUHC. What we wanted, V prime of t equals 2. And again, you do all of that and you don't have this first line. Have you proved that the acceleration equals 2? You've proved that V prime equals 2. It's annoying, but that is definitely part of it. And I mean, it could be a full point. Like everything's it's just full points on the way they grade them. So, right. Good stuff. We will do the calculator active one tomorrow. We'll have time to finish, get a bunch of this done tomorrow. This one really is a lot of actual I think after the first page, it's just 3 or 4, just 3 actual AP FRQs, which again are never ones that you will see, but you can't do the 2-dimensional unless you can do the 1-dimensional. Got a couple more seconds to. I'll have the review sheet for Unity for you guys tomorrow. It's pretty long. I might actually give you guys a day in class next week to work on it. We'll see. Don't hold me on it. We will. Is that still not going to be nearly enough time? That being said, you guys know a lot now. We go from knowing how to do like no FRQs to being able to do half of like at least AB FRQs because they all have like an integral component to them.